Hey there, Eli coming at you again from the fish rooms of OSA Coventry, here today with a weird animal. I've got behind me here these glowfish. They are a species of tetra, but these are kind of a controversial critter for a couple of reasons. So as you can tell, these animals actually glow, hence the name glowfish. These are a trademarked animal. These are produced, these are farmed to have this coloration, but they are truly a species of tetra, usually a variant of a white skirt, black skirt tetra, something of the like, and there are a few other species that this technique is done with as well. But as you can see behind me here, these fish almost have that dyed, really bright, vibrant color appearance to them in comparison to the typical solid white or silvers that you would see with the wild varieties of these tetras. How exactly is this possible? These fish are what we call a GMO, and these are actually genetically modified animals. And where they get this beautiful, vibrant coloration is from the DNA of some of your luminescent critters in the wild. So a lot of times, this comes from either coral DNA, jellyfish DNA, and this is something that is known as GFP in the scientific community, or green fluorescent protein. As much as some of these other proteins are fluorescing in other colors than green, that is basically the gene that codes for this sort of coloration in these animals. So you see behind me, these fish look very vibrant under the white lights, but if I was to switch this light over to the blues, these animals actually glow under actinic lighting. Under this UV or blue spectrum of lighting, these fish really pop. So this makes them a really fun addition to a freshwater aquarium in the home, especially if you have that option for a blue light over the tank. You can just really see how vibrant and bright those colors actually pop against those blues. And that is not necessarily bioluminescence. That is this animal exhibiting fluorescence against those wavelengths of light, which is just a really cool thing to kind of observe. So this is very similar to keeping corals in a reef tank, how if you have lighting that is more in the blue spectrum versus your white spectrums of light, if you're heavy on those actinics, heavy on those blues and UV spectrums, your corals are going to look a lot different than they do under white lighting, and that is for the exact same reason. And a lot of those corals are where this genetic information comes from to code for that within their tissues. Now, as much as it seems kind of strange to select for that sort of thing, to actually genetically modify the DNA of these animals to produce that glowing pattern just for the sake of keeping them in an aquarium, this technique was actually developed as a very useful scientific tool. A lot of medical research is actually done on some of your smaller vertebrate animals. Oftentimes, things like zebra danios and perhaps some smaller tetras, even animals like amphibians such as clawed frogs, are used as very valuable indicators for human medicine. There are a lot of studies, a lot of genetic studies, a lot of cancer studies, and other very important medical research that are done on some of these indicator species in laboratory settings. The technique of actually splicing this GFP protein into genetic information in animals is actually used as a way to identify how certain medical procedures are actually influencing these animals. So sometimes this can be used to study cancer cells. This can be a very useful way to actually visibly see where cancerous tissues might be building in an animal's body. This is a very useful way to actually positively identify without further analysis, just by the use of UV lighting, to kind of fluoresce and see if those cancerous tissues are building in certain animals. So that is really where this technique came from. It is, as much as it seems like kind of a funny thing to induce in a fish, this has very strong roots and very practical applications to human medicine and some very important scientific studies. So kind of an interesting thing to be able to see. Genetic modification has been used in a lot of other very important fields in science. It has been used in agriculture as a way to increase production on certain crops, or kind of make certain crops a little more tolerant to different climates, which is a great thing when considering feeding large quantities of humans. There are methods in which certain genes can be taken from other animals, other crops, other plants, and spliced with the DNA of crops that are already known producers. Some examples of this are frost-tolerant strawberries. So for berry production, berry farming, it is one thing that is a limiting factor for the production of strawberries is climate. And in areas that frost might occur for longer times throughout the year, your crop yield is severely hindered by that cold weather. But there are certain varieties of seeds that are actually produced that have the proteins like an antifreeze protein from other plants or other animals that allow for these strawberries to be a little more freeze tolerant. So if you experience a snap freeze in the middle of the production season in some of your colder climates where these berries are still produced, that you really still have a decent yield in the long run. So there are a lot of examples in which this sort of technique, this sort of genetic modification procedure has been used to introduce very useful traits of certain animals, certain plants, and certain other organisms to make a more useful end product for those agricultural, scientific, and medical fields of research, which I just find really fascinating. So as much as it is a controversial topic, as much as it is a strange idea that in the current times the scientific community is capable of such things, capable of altering the DNA and the structure of some of these animals, some of these other organisms, it is really a very fascinating idea that this is something that we are able to watch unfold firsthand. So I hope you all found the concept of these beautiful glowfish as a really interesting thing, if nothing more than just a conversation starter. As much as that concept of GMOs is a really touchy or strange subject, it is very interesting to be able to see this thing in firsthand. And it is hard to deny that these are a very beautiful animal regardless. As always, thank you all for tuning in. Please feel free if you have questions, comments, suggestions in the comment section below. You can leave those for me. And as always, keep it fishy.